The second objective of topic 5, inverses of radical functions, is to prove if two functions are inverses of each other. So if you're given two functions, can you prove that they are inverses of each other? All right, so if you're going to do this, there's three ways to determine if two functions are inverses of each other. The algebra way, which we've already done, you find the inverse of one and see if it equals the other. And so I'm not going to necessarily go through that. All you would do is pick one and then find the inverse of it and see if it equals the other one that's given. Step 2, though, the other one is to compose, and I am going to go through this, compose one function into the other and see if it equals x. If it equals x after you do that math, because again, they're symmetrical about the line y equals x, then they are indeed functions or inverses of each other. And then finally, the third one is to graph them. And the graph, the two lines are symmetrical about the line y equals x. And we've talked about that. Y equals x. Three ways. I'm going to go over the second and third way because you've already practiced the first way. Just find the inverse of one and see if it equals the inverse of the other. If it does, then yes, the two given functions are indeed inverses. So I'm going to go down to the middle piece here. State if two inverses are functions by compositions, or composition. So I'm going to go over number 8, and then I'm going to have you try number 7 on your own. And so if I was going to compose one into the other, composition means, again, I have g of n and f of n, all right? So in order to compose one into the other, I have to put one function inside of the other function. So I'm going to pick the linear function to be the piece that is going to consume the other function. Let me say it like that. So I'm going to have the notation g of f of n, all right? Meaning that f of n is going to go inside of g of n. Meaning then that there is a variable, g of n is, so I'm going to write g of n here. 3, the variable n, I'm going to replace with parentheses, all right? And I'm going to make them big because if you notice, this entire piece has to go into that n. So 3 times the parentheses and then minus 3. Now, to compose f of n inside of g of n, I need to just replace the n variable here. That's why I wrote parentheses. It's always important to write parentheses whenever you're composing something. I'm going to replace the variable n with this function f of n. So I'm going to write n plus 3 divided by 3. All right? Now I just simplify it to see if it equals the variable x, in this case n, because we're working with n's. And so to do this math, I have g of n equals 3 times n plus 3 divided by 3 minus 3. This multiplication right here becomes 3 on top, because this is technically over 1, so 3 on top. There's a 3 on top and a 3 on bottom down here, so I can cross out that 3 and that 3. So now I'm left with n plus 3, so g of f of n, sorry, that's the new notation because I'm composing one into the other. G of f of n equals n plus 3 minus 3. And then finally, 3 minus 3 becomes 0, so my composition of g of f of n equals the variable n. So because it equals n, they are indeed inverses. So I need to write that. They are inverses of each other. Meaning, the given functions here, g of n and f of n, these two right here are inverses of each other because I composed one into the other, and I found out that it did equal the variable n. It's just one strategy to use. So go ahead and try to compose f of n into g of n. Right here. So I want it to see g of f of n. So you're going to put the function f of n into the variable for g of n and see what you get when you do the math. So go ahead and pause the video and try that. At this point, you should have paused the video and tried to compose f of n into g of n, and this is the process for that. G of n, I need to replace the variable n here of the g of n function and put that into it. So I'm going to write parentheses, -2 not times n anymore, but times this new function f of n. So I'm going to put -1/2 n. Alright? Now, to do that math, so I'm going to continue this g of f of n equals -2 times a -1/2. There's a 2 on top, 2 on bottom, they go away. Negative times a negative becomes a positive, so I'm left with +1n. Or just n. Because it just equals the variable, these two functions are indeed inverses of each other. And again, if you couldn't do this math, -2 times -1/2 in your head, then try your calculator, type it as is. But if you didn't get n for your answer after you compose the two of them, please raise your hand so we can talk about it. One last thing I want to show you in this video is stated the given functions are inverses by graphing. Alright? So I'm going to graph number 5, and then I'll have you try to graph number 6 on your own. So for number 5, I would go, you could either use your calculator for this, or go to Desmos, and I'm going to go to desmos.com. I'm already there, I have things open from previous videos. But I'm going to graph the first function, which is h of x equals -3 minus x divided by 3. So, h of x equals -3, I got to put that in parentheses because it's a grouping, -3, what was it? -3 minus x, close the parentheses, all that is being divided by 3. That's my first function. I hit enter to go down to the next option. Next function, f of x equals -x minus 4 divided by 2. F of x equals, I don't have a very good memory, -x minus 4 divided by 2. -x minus 4, I got to put parentheses around that, divided by 2. So, I need to compare it about the line y equals x, alright? If you notice, my function in blue and my function in green, they do not look like inverses. This is the y equals x line. It is not the same above the line as it is below the line. So, because of that fact, they are not inverses of each other. I can check that visually and just see that they aren't, but and a couple other rules, remember. The x-intercept of the given function in blue is -3, 0, meaning that that should be the y-intercept of the inverse function, or the function in question, which is green, down here, and it is not. It was -3, 0, this one's 0, -2. That's another way to just check your work, but again, I could look at it visually and see that it's not. So at this point, go ahead and pause the video and try graphically to state number 6, if these two functions, g of x equals -5 minus 1/2 x, and f of x equals -2x minus 10, are inverses of each other. So please pause the video and try that. You should have paused the video and tried to graph the next number 6 on your own, and here's the picture of the graphs g of x and f of x. G of x is the blue line, f of x is the green line, compared to the line y equals x. If you look at it, on top of the y equals x line and on bottom, visually looks to be the same, looks to be symmetrical, so it looks promising as if they are inverses. Let's check the math though. The given function, or the blue one, the y-intercept is 0, -5, and the x-intercept of the other one, f of x, is -5, 0. So the y-intercept of the first function becomes the x-intercept of the next function, and the x and y values switch. So because visually they look to be the same, symmetrical on the top of the line y equals x and the bottom of it, and because of that rule of -5, 0 for the x-intercept of the green line, becoming 0, -5, the y-intercept of the blue line, these are indeed inverses of each other. Okay, so at this point, if you didn't get this and you can't state that they are inverses of each other, please raise your hand so we can come talk about it.